Good morning, students. Today in this lecture, we are going to start a new topic about Babcock Wilcox boiler and lamont boiler. First, coming to the Babcock Wilcox boiler, we can observe the diagram of Babcock Wilcox boiler, and by using of the below components, we are going to construct the Babcock Wilcox boiler. I can show you these components in this Babcock Wilcox boiler one by one. See here, we can observe here D represents the drum, means nothing but of a boiler shell which is nothing but of a drum, and DTH means nothing but of a downtake header, and WT means nothing but of water tubes which we can observe here, and BP means nothing but of baffle plates which is used for deflecting the hot gases in a zigzag way upon to the fire tubes, and G means nothing but of a grate where we are going to do combustion process, and FD is nothing but of a fire door where we are going to give coal upon to the grate. See here, MC is nothing but of a mud collector. The way the sedimentations which has been formed in the water is collected here by using of this mud collector, and WLI. WLI means nothing but of water level indicator. Water level indicator shows how much water is there in the boiler drum. And coming to the PZ pressure gauge represents the steam pressure, and ST represents the superheated tubes. We are having here superheated tubes, and SV represents the safety valve. MSV means nothing but of main stop valve, and APP means nothing but of anti-priming pipe, and here we are having a lower junction box, and here we are having upper junction box. FV is nothing but of a feed valve. This is what the components of Babcock Wilcox boiler. By using of these different components, we are going to construct this Babcock Wilcox boiler here. See, this is what we have studied up to now about the construction of Babcock and Wilcox boiler. See, the first one is about steam. First one is about the steam and water drum, means nothing but of boiler shell, and here we are using water tubes, and uptake header and downcomer, grate, furnace, baffles, superheater, mud box, inspection door, dampers, which we can show in the diagram itself. See, coming to the steam and water drum, in the boiler shell, half of the part is filled with the water and half of the part is filled with the steam. We can observe here that the half part has been filled with water and the remaining half is filled with the steam, contained with the steam. The boiler shell is about 8 meters length and 2 meters in diameter. And coming to the water tubes are inclined in position, and the inclined position is about 10 to 15 degrees, which is used for water circulation. So here these tubes are connected to the uptake header and downtake header. See, we can observe here. Here we are having the uptake header and downtake header. These are the water tubes which are connected to the upper take header and downtake header. See, coming to here, uptake header, the drum is connected to a end to the uptake header by short tubes and other end to the downcomer by long tubes. Here it has been, this downtake header and uptake header has been connected to the boiler drum by using of pipes. At the uptake header we are having a short pipe, and for downcomer we are having long tubes which has been connected to the boiler shell. And coming to the grate, upon the grate the coal is feed from the fire door which is used for combustion process. Upon the fire is kept below the uptake header which we can observe in the diagram, and baffles are used to deflect the hot gases upon to the these water pipe, water water flow pipes. Superheater is nothing but of boiler is fitted with superheater tube which is placed just under the drum and above the water tubes. And mud box is nothing but of what are the sedimentations formed in the boiler are collected through this mud, through this downtake header, and by using of this downtake header, these sedimentations are collected is nothing but of a blow of cock. Inspection doors are there in the diagram, which we can observe there. It is used for the doors. By opening of these doors, we can enter into the boiler for cleaning and inspection purposes. See the working of Babcock's and Wilcox boiler. Here we can observe that the water in the boiler shell, the water in the boiler shell is going to be entered into the downtake header by using of this long pipe, and after entering into the downtake header, it transfers in up to the it enters into these water tubes. The water which has been collected from the boiler shell will come to the downtake header. By using of this downtake header, the water enters into these water tubes, and it is going up to, it enters up to the uptake header, and this uptake header has been connected to the this boiler shell. And here by using of this feed valve we are feeding water, and by using of this water level indicator we are going to check how much water is there in the boiler shell, and by using of this pressure gauge we are going to check the pressure value of the steam. Here upon the grate, by using of this fire door we are going to feed coal upon to the grate, where here the combustion process takes place. After the complete combustion takes place, the hot gases which are produced are generated by use here upon the grate. The hot gases will rise up and enters upon to the water tubes, and the baffles which are provided here are deflects these hot gases in a zigzag way, and enters at last these hot gases will enters into the atmosphere. What is the water coming from the boiler shell, it enters into these water tubes. Due to these hot gases, the water in the water tubes is going to be got heated, is going to get heated due to convection process, and it has been changed into the steam, and the steam is going to be entered here in the half part of the boiler shell. See here, after the steam has been entered here, it is entered into the anti-priming pipe. In anti-priming pipe, the wet means nothing, the moisture content has been removed here. The in anti-priming pipe, the moisture content in the steam has been removed, and the steam will enters into this superheated steam, and the steam has been converted into the superheated steam. And after converting the steam into superheated steam means nothing but of raising the temperature of the steam in the superheater, means here with a low temperature here, after priming it enters, the steam is going to be entered into superheater tubes, and here the temperature will rises, and after the steam will moves into the main stop valve. Here the main stop valve controls the steam, and it stores in the steam in the steam storage, and it gives whenever the steam has been required for generating of the power. This is what about the Babcock's Wilcox boiler working principle here. See here, working coal is fed to the grate through the fire door and is burnt. See what I have shown you there at the diagram. The hot flue gases rises up and pass across the left side portion of the water tubes. The baffle deflect the flue gases, and hence the flue gases travel in the zigzag manner. See here, you can observe that the hot gases which are produced here will going to be passed in a zigzag way here, in a zigzag way, The hot gas are deflected by the vapors to move in the upward direction, then downward and again in the upward direction over the water tubes and along the superheat. The flue gases finally escape to the atmosphere through chimney, what I have shown in the diagram. See what about water circulation, how the water is going to be circulated here. That portion of water tubes which is just above the furnace is heated comparatively at a high temperature than the rest of it. See when these hot gases are See, when the hot gases are rising upwards, the water inside the water tubes are going to be heated. See here, water, its density being decreased, rises in the drum through the uptake header. Here, the steam and water are separated in the drum. We can observe that the water, steam and water in the boiler shell has been separated here, and steam being lighter is collected in the upper part of the drum. The water from the drums come down through the downcomer into the water tubes, which I have shown in the diagram. A continuous circulation of water from the drum to the water tubes and water tubes to the drum is thus maintained. The circulation of water is maintained by convective currents and is also known as natural circulation. Here we are having damper is fitted as shown to regulate the flue gas outlet and hence the draft. The boiler is fitted with the necessary mountings, the pressure gauge, water level indicator, and a safety valve and a blow off cork, what I have shown you there in the diagram itself. And some of the applications of Babcock's and Wilcox boiler are, see, the main application of Babcock's and Wilcox boiler to produce high pressure steam in power generation industries. For getting high pressure steam in power generation industries, these Babcock's and Wilcox boiler are going to be used here. We are having some of the advantages of Babcock's and Wilcox, that the overall efficiency of the boiler is high. The steam generation rate is higher, about 20 ton per hour at the pressure 10 to 20 bars. The tubes can be replaced easily. The boiler can expand and contract freely. It is easy to repair, maintenance and cleaning. These are some of the disadvantages. It is less suitable for impure and sedimentary water. Hence, water treatment is very essential for water tube boilers. Failure in feed water supply, even for a short period, the maintenance cost is high. This is what some of the disadvantages of Babcock's and Wilcox boiler. See, once again, I am going to explain you the Babcock's Wilcox boiler working principle. See, the water which has been contained, the half portion of the boiler shell is going to be contained with the water, and the other portion of the shell is contained with the steam. See, the water which is contained in the boiler shell is entering into the downtake header by using of this long pipe. After the water has been entered into the downtake header, the water is going to be entered in the water tubes. The water which is having low density is going to be raised upon to the uptake header, and after, see here, by using of this fire door we are going to feed coal upon to the grate, and here after complete combustion has been takes place, the hot gases are going to be raised upon to the water tubes. And what is the water which is inside the tubes due to these hot gases? See, these hot gases are going to be circulated among these water tubes in a zigzag way, and at last these hot gases are going to be appeared into the atmosphere, dispersed into the atmosphere. See, due to these hot gases, what are the water in the tubes are going to be heated, and is going to be converted into the steam. The steam which is has been converted by using of this uptake header has been sent into the steam collected place, and the steam is going to be entered into the anti-priming pipe, and the wet steam or the moisture which has been collected in the steam is removed by using of this anti-priming pipe, and it is going to be sent into the superheated tube, and the steam is going to be entered into the superheated steam, where the superheated steam tubes are going to raise the temperature of the steam, and at last, after converting the steam into superheated, the steam is going to be entered into the main stop valve. Here it is going to be collected, and whenever the steam is required from here, the steam is going to be used for the power generation process. This is what about the Babcock's Wilcox working principle, and these are some of the accessories which we are using here for the Babcock's and Wilcox boiler. And coming to the next topic, we are having high pressure boilers. High pressure boilers, see here, boilers which generate steam at a pressure with a range of 80 to 160 bar, a temperature about 5000 degrees Celsius, producing capacity of 30 to 50 tons of steam per hour, are called high pressure boilers. What are the pressures here? 80 to 160 bar, and temperature should be maintained at 5000 degrees Celsius, and the steam producing up to 30 to 650 degrees tons of steam per hour are called high pressure boilers. In modern power plants, high pressure boilers are universally used. Water tube boilers are generally used as high pressure boilers. See, we are having the following are the important high pressure boilers which we are using here in thermal power plants or steam power plants, that Lamont boiler, Benson boiler, Lofer boiler, and Wilcox boiler. These are some of the high pressure boilers which we are using here. In these high pressure boilers, in this video we are going to learn about Lamont boiler. See, coming to the Lamont boiler, here we can observe the working principle of the Lamont boiler, that this the pump is going to pump cold air into this air preheater, where here the by using of this air preheater, the air is going to be get heated, and it is going to be transferred hot air outside inside the furnace, used in the furnace. See here, the pump is going to be the pump is going to transfer the cold air into the air preheater, where here the heating has been generated, and the heat is going to be hot air is used in the furnace purposes. See here, the pump which we are using here, feed pump. The feed pump is feeding water up onto the economizer, where the heating, the temperature has been generated here, and the water which is going to be feed by using of this pump enters into the economizer. After the temperature has been generated, it is going to be entered into the steam and water drum, and from the steam and water drum it is going to be entered the water, feed water which has been feeded here is entered into the forced circulation pump. By using of this forced circulation pump, it enters into the this Lamont radiant. Here it is going to be converted into vapor formation, and again these vapor formed or water vapor forms which has been formed here is again enters into the steam and water drum, and from the steam and water drum it is going to be entered into the convective superheater for converting the fully vapor formation, and it is going to be entered into the turbine. This is what about the Lamont boiler, how it is going to be worked here. Once again, I will explain you about this Lamont boiler, that in the pump, by using of this pump, cold air is sucked and transfers into the air preheater. Here the air has been heated, and it generates hot air outside for using the hot air in the furnace for combustion process. See here, the pump which we are having here, the pump is used to feed water into the economizer. Here the feed water which enters into the economizer has been heated or raises the temperature and send the feed water into the steam and water drum. Here the feed water which has been entered into the steam and drum water is again forced again enters into the forced circulation pump. By using of the forced circulation pump, it is going to be entered into the lamont boiler, and here it is the feed water is going to be converted into vapor formation, and again it is going to be sent into the steam and water drum, and from the water steam and water drum it's again sent into the convective superheater where here the vaporization takes place and it enters into the turbine. This is what about the lamont boiler working principle. Here we can observe the diagram, the lamont principle here also in the same way, that the cold air by using of this blower fan is going to be entered into the air preheater, where here the heat generates and it gives hot air for complete combustion, for doing complete combustion process, and from hot well water from hot well is feeding up onto the economizer, where heat takes place and it enters into the steam separating drum, where the steam and water are going to be separated here. From these it is going to be entered into the convective evaporator. See here it enters into the convective evaporator, and from the convective evaporator and the feed water which is coming from economizer is going to be entered into this pump circulating pump. By using of this circulating pump, by distributing header, it transfers into the distributing header, and then from the distributing header it enters into the radiant evaporator, and from the radiant evaporator it enters into the superheater, and it superheats, and again it is going to be transferred into the turbine, superheated steam to prime mover. This is what about the lamont boiler. And what are the hot gases? Here some combustion has been takes place, and what are the hot gases producing is going to the upwards to exhaust gases outside to the atmosphere by touching of these economizer as well as convective evaporator and radiant evaporator. See here, this is the principle of the lamont boiler. This boiler works on basic principle of forced convection. If the water is circulated by a pump inside the tube, the heat transfer rate from gas to water increases. It is the basic principle of the lamont boiler. See here the construction. This boiler is the first forced circulation boiler. This boiler consists various parts which are as follows. We can observe this economizer. Economizer used to preheat the water by using remaining heat of the combustion gases. It increases the boiler efficiency. See here, the economizer is used to preheat the water by using of remaining heat of the combustion gases for improving the boiler efficiency. And coming to the centrifugal pumps, it is going to pump the circulation water inside the boiler. Pump is driven by a steam turbine. The steam turbine for the turbine is taken by the boiler. Here, the evaporator is there. The evaporator tubes, in the evaporator tube, the water is going to be circulated. See, and this cools down the water inside the evaporator. See here, the grate is nothing but of where we are doing the combustion process. And in the furnace, vertical furnace is used. The main function of furnace is to burn the fuel. Superheater is there. The steam generated by the evaporated tube is saturated steam. If it directly used in a steam turbine can cause the corrosion. So the saturated steam sent to the superheater where it can increase the temperature of the steam. See, if we are going to use the steam turbine steam directly, it is going to form corrosion, so it is enters into the superheater, then it increases the temperature of the steam here by using of the superheater. See here, water steam separator drum is going to separate the steam as well as the water here, and air preheater which he preheats the air before entering into the furnaces. What I have explained you about the working principle of lemon boiler near the diagram, we are going to get the step by step manner here in a point where that lemon boiler is a forced circulation boiler. Forced, why we are using forced means as we are using pumps for pumping the air or feed water into the boiler. Internally fired water tube boiler means the combustion is going to take place inside the boiler itself. The fuel is burned inside the boiler and the water is circulating by a centrifugal pump through evaporator tubes. In the tubes, the water is going to be circulated here. The working of this boiler is as follows. A feed pump forces the water into the economizer where the temperature of water increases. See here, you can observe this. Here, the feed water is going to be sent into the economizer where the temperature of the water is going to be increases here. And coming to here, we can observe the fuel is burned inside the boil feed to the where temperature of the water forced into the evaporator tube by using of centrifugal steam pump. Here we are using the pump for forcing into the economizer here. And coming to here, water passes 10 to 15 times in the evaporator tube. The mixture of saturated steam and water is formed inside the tube. Here, as the water is circulating in the evaporator, water is circulating in the evaporator up to 10 to 15 minutes. See here, in the evaporator, the mixture of saturated steam and water is formed inside the tube. The mixture sends to the steam separator drum which is outside the boiler. I have shown you in the diagram about the steam separator which can separate the steam and water. Steam from the separator sends to the superheater where the super saturated steam converted into superheated steam which I have shown you in the diagram itself. The water again sends to the economizer where it again passes by the evaporator tubes. The air from the air preheater enters into the furnace where fuel burns. The fuel gases first heat the evaporator tube and then passes by the superheater. These gases from the superheater again used to preheat the air into the air preheater before exhausting to the temperature. This is what about the working principle of lemon boiler, which we can observe here that the cold air is going to be entered into the air preheater. Here the cold air is going to be preheated and it is going to get some hot air. It is going to convert into hot air and the hot air is exhausted outside and it is used for the furnace purposes. And here we are going to feed the water by using of this pump. We are going to feed water upon to the economizer where the water temperature is going to be raised in the economizer and it is going to be entered into the steam and water drum. After it is going to be entered into the steam and water drum by using of this, here the steam as well as the water is going to be separated here and the water is going to be entered into the forced circulation pump. By using of this heat pump, it's enters in the water is going to be entered into the lemon boiler. Here the water is going to be converted into water vapor formation and the water vapor formation has been entered again into the steam and water drum, and from the steam and water drum it is going to be entered into the convective superheater for converting the steam into fully vaporized form, and it is going to be entered into the turbine formation for turbine for doing the power for power generation. This is what about the Lamont boiler working principle, which we have studied one by one in a stepwise. And coming to here, we are having some advantages that it can high pressure boiler. It is flexible in design. For designing these lemon boiler, it is very flexible. We can design. This boiler can be reassembled in natural circulation boiler. It is designed in a natural circulation boiler. It can easily start. It has high steam generation capacity of about 50 ton per hour. This boiler has higher heat transfer rate. This is what about what we have studied about the lamont boiler. See, in this video we have studied about the working principles of Babcock's and Wilcox boiler, and about the Lamont boiler, how the construction and working principles of Lamont boiler and Babcock's and Wilcox boiler. This is what about the boilers, and the remaining boilers we are going to study in the next video. If you are having any doubts, please mail to this mail ID or call to me. Thank you.